Hello, everybody. Okay, we are on our next little mini unit, which is mostly about finding angles in polygons. But we start off with a little kind of review lesson on what a polygon is and how to classify them. So a really big idea, folks, we're going to review how you name a polygon based on the number of sides it has, and then if it's convex or concave. Those are basically the big ideas. So let's review what is a polygon. So that's this left side right here. It says review. So determine if a figure is a polygon. Now remember, folks, a polygon is a straight-sided figure that's closed and has no curves. So big idea again is that it has to have straight sides. If I look at this first example here, do we agree that it has straight sides? Yep. Is it closed? Yes. Are there curves? No. So this is a polygon. If we bump over here to number 2, I'm hoping you're thinking, no, this is not a polygon, right? Because right here it curves. We can't have any curves in our polygons. On this third example, I'm hoping you're thinking no, right? Because it's opened right there. It's not a closed figure. And then lastly, our fourth example here would be another yes, because all your sides are straight and it's closed. Perfect. Okay. Now, the next little bit here is classifying the polygon by its number of sides. So I'm going to give you a second, see if you can match these for us, and then we'll see how you do, okay? So put whatever letter corresponds to the number of sides. I'm hoping that was an easy task for you, so now I'm going to go through them quick. So a 3-sided figure we should know by now is a triangle, so that's letter E. 4-side, that's what we were doing all 2 chapters ago. So that's a quadrilateral, C. 5 sides is a pentagon, H. 6 sides would be our hexagon, which is G. 7 sides is that weird one, hepta, which is A. 8 sides I think we know is an octagon, like an octopus has 8 legs. 9 sides is a nonagon, so F. And then 10 sides is a decagon, like decade has 10 years, a decagon has 10 sides. All right, so up until this point, nothing new. This is a review from probably about a month ago. Now we're going to kind of get into something a little different. So besides naming a polygon based on the number of sides it has, you can also decide if it's a convex polygon or concave. So a convex polygon is a polygon with vertices that point outward. What does that mean? It basically just means that all of my vertices point outside our figure. Like they're pointing like this way out, right? They're pointing outward. Whereas a concave polygon, it caves in on itself. You see the word cave is in there? So we say that it caves in. And what do I mean by that? Well, do you see how this point right here and this point right here, they're inside our shape, right? You see like they're inside, whereas all of these points on our convex polygon don't point inward. So on these bottom examples here, it says determine if the polygon is convex or concave. Well, if we look, you guys see how this vertice right here is kind of on the inside of our shape? So this would be concave. It caves in. It's going inward. Okay, our next one, it looks like all of our vertices are pointing outward, right? So that's convex. Our next one here is a triangle. Again, all of our vertices are kind of just pointing outward. Convex. And then our last one here, again, do you guys see how it dips in right here? It's going inward, so it's concave. Beautiful. All right, when you're ready, we have 3 more vocab terms to talk about. Okay, so not only can you name a polygon by the number of sides it has, you can also decide if it's convex or concave. And now these last 3 talk about the angles and sides, okay? Equilateral. Think of when we talked about equilateral triangles. Remember, lateral means sides, and equal means equal, so equal sides. That's what that technically means. So if you have an equilateral polygon, all of your sides are congruent. Again, you guys notice we have those tick marks telling us that all those sides are the same? Our next one over here, equiangular. Remember, equal, angular, angles. Equal angles. So all angles are congruent. So in this example here, there's doing right angles in the corner, but even still, those are 4 right angles, which means they are all the same. Now, a regular polygon is a polygon with all sides and angles congruent. Sides and angles. So you got to remember, they're going to try to trick you, right? They want to see if you really know your stuff. So you have to make sure that every side has a tick mark like this. And then that every angle has an archy mark. Because again, they're going to try to trick you to see if you really know what's going on, all right? So now let's practice this idea. Decide whether the polygon is regular. Explain. So remember, regular means equal sides and equal angles. So if we look here, I look at all my angles. It appears that all of my angles have an archy mark. So that's great. It is equiangular. However, if I look at my sides, I have 1 tick mark, 1 tick mark, 1 tick mark, and then I have 2. I needed just to have 1. So they're trying to trick us there. So this is not regular. And it says explain, and we're going to say sides not congruent. Our sides are not equal. Perfect. Very good. All right, let's check the next one. Let's see. Do all of our angles have an archy mark? Yep. All of our angles are good. Now let's check our sides. 1 tick mark, tick mark, tick mark, tick mark, tick mark. Hey, this one is regular. Why? We're going to say congruent sides and angles. It fit the definition. Okay, then our last one here. Well, right away we can already see we don't have any markings on our angles. All we have are our tick marks on our sides. And that's not enough to say something's regular, so we're going to say not regular. Oops. Not regular, folks. And we're going to say angles are not congruent. Okay, perfect. So now let's see in these next 3 examples, can we piece it all together? Can we decide if a polygon is convex or concave, and then decide if it's equilateral, equiangular, or regular? So do we know the definition of all of these words? And it's kind of a lot. So let's go through it together. Is it convex or is it concave for this first one? I'm hoping you're thinking convex, right? Because we don't have any vertices pointing inward. Now let's look equilateral. Are all of our sides equal? Tick mark, tick mark, tick mark, tick mark. Yep. Are all of our angles the same? I have 1 archy mark, and then I have 2, so it's not equiangular, which means it can't be regular. Perfect. Good job. All right, the next one here. Convex versus concave. I'm hoping you're thinking concave because of this guy right there. It's dipping inward. Very good. Okay, let's check our sides. Are all of our sides the same? 1 tick mark, tick mark, tick mark, tick mark, tick mark. It's equilateral. Now, do we know anything about our angles here, folks? Nothing, right? There's no marking, so we can't decide if it's equiangular, which means we can't decide if it's regular. All right, next one. Convex or concave? Should be convex. If We look at all of our sides, tick mark, tick mark, tick mark, tick mark. It's equilateral. Let's check out our angles. Right angle, right angle, right angle, right angle. All of our angles are the same. So since it's both equilateral and equiangular, it's also regular. Very good. Very good, folks. And then as always, we always like to finish off with a little bit of algebra because it's our favorite. And it says, answer the following questions about the regular polygon. So they're telling us that these are regular polygons. So it says, find the perimeter. Well, now remember, folks, perimeter is if you were to walk all the way around your shape, how far would you go? So if we walk all the way around that hexagon, how far would we go? Well, since it's regular, if this side's 4, all of our other sides are 4 inches. So really, how many 4s do we have there? We have 1, 2, 3, 4, 5, 6, because it's a hexagon. So 4 times 6 equals 24. So the perimeter would be 24 inches. Okay, our next one over here, find the value of x. Remember, it's regular, so all of our sides are the same, right? So what's an equation we can write to solve for x? Well, I'm hoping you're thinking 4x minus 27 equals 21. And now we have a pretty simple 2-step equation to solve. Add over our 27, drop down that 4x, and then we divide by 4. So x should be 12. Perfect. And now we're moving into the angles inside here. It says find the value of x. So again, remember it's regular, so all of our angles are congruent. So if I'm looking for the value of x, I know that these two angles are the same, right? So 3x plus 9 equals 108. Again, just a 2-stepper, subtract the 9 over. 3x, 108 minus 9 is just 99. Divided by 3. X should be 33. Perfect. Same thing on this last one, folks. It looks like we have an octagon, right? And we know that all of our angles in here are congruent because it's a regular polygon. So how do we find x? Well, we simply just put our 2 angles that we know things about equal to each other. So 5x minus 45 equals 135. Add over 45. So we get 5x is equal to 180. Divide by 5. 180 divided by 5 is 36. All right. Good work, folks. Thank you for watching, and I will see you tomorrow. Have a super day. Goodbye.